Hey guys, so far we have looked at a concave mirror and we've seen the various types of images that can be formed, right? We can recall the last table that we saw, wherein we change the position of the object, the position of the image will also change, so will the properties, right? So today what we are going to do, we are going to look at how to draw diagrams for all of these cases. Basically what we call them is ray diagrams. So we're gonna get familiar with all the ray diagrams for concave mirrors for now. Okay. Before we get into that, I'm quickly going to recap the same concept that we've seen, right? That is a concave mirror, and we're going to look at the basic diagram that we'll always follow: the pole, the focus, and the center of curvature, right? So this is a constant in all the diagrams, and this is going to be there for every diagram that we make. Now once we start drawing, there are three rules that we need to keep in mind when it comes to ray diagrams for concave mirrors. I'm going to list out all the three rules again with the help of this diagram. So the first rule is, right, the first rule would be, right, now these rules are pertaining to how light travels with the mirror. So I am just going to first draw a mirror, pole, focus, center of curvature. Right, first is something that we are familiar with already. We have seen this a couple of classes back. The first rule tells me what happens if a light ray is moving in such a way that it is parallel to the principal axis, this line. And we already know that if that happens, it is going to bounce and definitely go through the point F, basically through the focus. That is the first rule of reflection in concave mirrors. The second rule is similar to it. It's actually what we call a converse. Basically what happens if this situation occurs in reverse. So now this is again a concave mirror, pole, focus, center of curvature. So by converse I mean incident is parallel to principal axis and the reflected ray goes through focus. Over here I'll say that incident ray goes through focus, right? You see the first ray itself is coming through focus, and since it is a converse, it would mean the reflected ray will become parallel to the principal axis. Notice the arrows when we are doing these diagrams: coming, going, coming and going, right? The third rule would be for an object that is, or for a ray of light more specifically, that goes through the point C. So what this rule will tell me is if a ray of light passes through C, then what happens is it will bounce back in the same direction. So even if it's coming like this, it will hit and then it will bounce back in the same line, right? It won't take any deviation. There is zero angle over here. It comes this way, it also goes back in the same way. Now why this is important is, when we are drawing ray diagrams for concave mirrors, we're going to need to use any two of these rules in combination to get our final diagram.